Alrighty, let's take a look at section 1.5 right here, which is measuring and constructing angles. A lot of information, as always, coming right at you. So let's get started. Let's take a look at the first term here. The first one is an angle, which is a set of points consisting of two different rays that have the same endpoint or vertex. Okay, so here's the thing. When we have a ray, an angle, it ends up being two rays, right? We have ray 1, and then we have ray number 2. And they happen to meet right here, which happens to be your vertex, where the two rays meet. When we look at this diagram, this right here would be the side of an angle, and there would be two. One right here, and there's also this one right there. That would be a side of an angle, or sides, because it takes two sides to make up an angle. Unless we have a straight angle, which happens to be pretty much a straight line. For our next term, we have interior of an angle. Those would be points inside. So anything that would be in here would be considered the interior of an angle. The exterior would be everything that is on the outer part of it. Let's go ahead and move along. The measure of an angle is considered the degree of the angle. Now, here are some key facts. You've got to know the difference between acute, right, obtuse, and straight angles. An acute angle is an angle that is less than 90 and greater than 0. Okay, if it happens to be 90, then it is considered a right angle. So that's why the next one, for an angle to be obtuse, it has to be less than 180, and the angle has to be greater than 90 for it to be considered obtuse. And then finally, we have a straight angle, which happens to be a straight line. So for the most part, visually, you should be able to understand what an acute angle is. This would be one that's less than 90 degrees. If it's 90, and you'll know it's 90 because the problem will tell you, or you'll see this little right angle symbol. If it's obtuse, it looks wide. Okay, it's got to be greater than looking this, wider than this. And then you got your straight angle, which happens to be your straight line. Exactly 180. Congruent angles, just like congruent sides, which have the same side length, congruent angles are angles that have the same measure. Okay. And then an angle bisector is a ray that will divide an angle into two congruent parts. So that's my angle. This would be my ray. And we notated segments to be congruent with the little tick mark. Right here, I know that angles are congruent because I'll put like a little arch right there, and I'll put a little arch just like that, and that's how I know that those two angles are congruent. Now, if it bisects, then obviously those angles should be congruent anyways. So those are some of our basic terms right here. Let's go ahead and move on. We've got the protractor postulate. Similar to that of the ruler postulate, look, if I go ahead and, now, how do we use a protractor? You do want to set up, there's like a little point right here, or an opening at point O. You want to line that up with the vertex, and then line this, one of the sides up with the ray. If you take a look right here, this would be considered 0 and not 180. And then let's go ahead, count the numbers going on the inside part of the protractor, and that'll take us to 140. Okay. Hopefully it makes sense that this isn't 180 because this is not a straight line. So there's no reason for this to be called 180. And you don't want to go outside counting down. It just doesn't make sense. All right. One important thing. This right here, we call this angle AOB. When we write down an angle, we're going to use 3 points, okay, to label the angle. We could technically call this angle O as well, but sometimes in problems that you're going to see throughout the school year is that angle O could be various angles. So that's why we choose 3 points and not just call it one angle. Because let's say right here, if I were to add this ray, and let's say that that's point C, angle O could technically be 3 different angles right here. It could be AOC, it could be COB, or it could be angle AOB. All from this, because they all have the same vertex. That's why you've got to use 3 letters majority of the time. We talked about all of these already. Okay, so that should be pretty simple. Angle addition postulate. Just like segment addition, make sure you set up your equation using the 3 parts right here. Okay. Small angle plus small angle ends up equaling the big angle. So don't forget to include that into your problem or when you're setting up your work. Okay. Angle RSP, right? Small angle plus the other small angle, angle TSP, is equal to the big one, which is angle RST. And so that's what they're showing you right here with symbols, and I just went ahead and rewrote that down for you as well. And let's move along. All right, with number 1, it says name 3 different angles in the diagram. Okay, remember, we use 3 points to name an angle. So if I start right here, and also when we use 3 points, it just can't be any random point. The point in the middle must be the vertex. Okay, so this right here, this angle F is the vertex. So one of the ways I could write this is angle EFH. I could call this another angle that's in the diagram is angle EFG, and then the third one we have angle HFG. Remember, I do not want to just say angle F, because angle F can be one of these 3 angles here that are listed. So that is a no-no. We take a look at number 3. Angle LMN is one. We have angle KMN as the other. And then the last one, angle LMK. This would be obtuse. The other 2 would be acute. And as you can see in all of these, angle M or point M happens to be the middle letter. That is your vertex. Find the indicated measure or measures. Okay, so once again, let's use angle addition postulate this time. And to find angle JKL, which is actually the whole entire thing, we're going to go ahead. This one works out nicely. Angle JKM plus angle LKM is equal to angle JKL. So we can go ahead and start plugging things in. This is 31 plus 85, and that's equal to angle JKL. And adding that up, angle JKL right here is 116 degrees. Okay, so that is the use of angle addition postulate. Next up on number 5, they're saying right here, we want to find angle RST. Okay, so how do we do that? If I know right here, I've got angle UST. If I add angle RST, that's supposed to be angle equal to angle USR, or the same thing as RSU. So let's see what we could plug in here. I've got UST happens to be 69 degrees. It's given right here. They tell us at the top, angle RSU or USR, that's equal to 91. So angle RST is the unknown, and we can go ahead and subtract 69 to both sides, and then we're left with 22 degrees. Taking a look at number 6. There is one key item there on number 6 that should stand out in that description. Give you a moment. Hopefully you see right here, it says that angle UXW is a straight angle, meaning it's 180 degrees. So they're saying that these two small angles combined end up equaling 180. So how about this? Small angle, angle UWV, x plus 20, plus the other small angle, which is VWX. Those two angles combined right here end up equaling the whole entire thing, which is angle XWU, the straight angle, which is 180 degrees. Combine all that, I've got 2x plus 20 is equal to 180. Subtract 20 to both sides, 2x is equal to 160, and x is equal to 80. Well, does it make sense? I sure hope so. I plug things in right here. 80 plus 20, that's 100. Plus 80 right here, that gets me a total of 180 degrees. And there you go. A few other key problems right here. Number 7, hopefully there's something in that diagram that you see. Highlight it right here. That means it's 90 degrees. So that means the two smaller angles will equal up to 90. So I could take 5x plus 57. And I like to set up angles by using parentheses. Both of those together ends up equaling 90 degrees. They may not tell you any of that right there. Okay? They don't. But looking at the diagram, they do give you that information. So we can go ahead and solve this out. I've got 6x plus, right here, 72 is equal to 90. Subtract 72 to both sides, and then we end up with 6x is equal to 18. Divide both sides by 6, and x is equal to 3. Now don't forget, that doesn't mean that you necessarily found the answer. They want you to find angles CAD and BAD, or else you're going to be BAD. Plugging things in, we got 15 plus 57, right? If we go ahead and plug in the 3. And that right there ends up getting me a grand total of, looks like 72. So up here, this better be 18, and it is. 3 plus 15 is equal to 18. So CAD is equal to 18 degrees, BAD is equal to 72. All right. 8 and 9, remember, what does it mean if they bisect? An angle is being bisected. It should tell you that they are equal to one another, because you're taking an angle and splitting it in half. So for example, like on number 9 right here, remember, if it's being bisected, then they're congruent. 4x minus 10 is equal to negative 3x plus 130. You solve for x, and I get x is equal to 70. But did you find your answer? No. Make sure you plug it back in to get your answer for angle PQR and angle PQS. And that right there concludes 1.5.